Hello everyone, welcome to the 47th IAH Congress Brazil 2021. My name is Ana Carolina Camargo and I'm going to talk a little about aquifer vulnerability. These are some abstract information of the work. The title is Spatial Analysis of Aquifer Vulnerability and Water Protection Zones in the Upper Tietê River Basin, and the other authors are Rodrigo, Nehara, Moreira, Cláudio, Benedito, Baptista, Leite, and Vitor, Vieira, Vasconcelos. So, introducing the theme, contaminated area is a location that contains concentrations of substances in conditions that could harm health and the environment. So, an important information here is that in all the state of São Paulo, Brazil, there is more than 6,000 areas, cadastres, but only in an area, in the Upper Tietê Basin, is more than half of these values, with more than 3,000 areas. So this is a very important information. And we can see on this figure here, the distribution by activities. And the most pollution is the gas station, with more than 70% of the areas. And in second, the industry, with 20% of the areas. And all this data and this information is available on CETESB. And the problematic of this is because the contaminated areas impact on water courses, wells, and aquifers. So suppose that this area here is a contaminated area. The substances not keep here in the soil, but the infiltration as well, like this figure showed to us, and then they keep on the water level. And this is very dangerous because it impacts on the water courses, the wells, like this figure here, and the aquifers. And because of that, the goals of the work are determine the vulnerability of groundwaters, identify the risked places, and estimate the risk for the exposed population. The study area is the Upper Tietê Basin. We can see on this map here the border, and it's located in São Paulo, Brazil. And we can see on the map as well the wells. It's more than 10,000 of wells on the Upper Tietê Basin. And the tools that we used are ALHSUD, QGIS, and Microsoft Excel. And on this table we can see the data and the source of them. So the contaminated area is available on CETESB. The wells is available on DEE and SAGA's website. And the hydrogeological units on IG. And all the sources are free public websites. So talking about the methodology now, we can start with the concept of aquifer vulnerability that indicates to us the fragility of groundwater in relation to contamination. And to estimate this aquifer vulnerability, we can use some models, and one of them is the Aquifer Vulnerability Index, or AVI, created by Van Stafford in 1992. And this method, the AVI, is defined by this equation, represented by the resistance, called C, is equal to the sum of the thickness divided to the conductivity. And when we resolve this equation, we have the resistance and consequently the vulnerability class of the aquifers. So if the resistance is 0 to 10, the vulnerability class of the aquifer is very high. If the resistance is 10 to 100, the vulnerability class is high, and if it is 100 to 1000, is moderated. And another information here is the hydraulic conductivity, that is a data that we need to use, and it's defined by the ease of the lithology allows with percolation, and we can determine the conductivity by this model here, created by ABGE in 1996, And all these variables are available on IAH's website, including the thickness. So all these informations are available on the IAH's website. And after we resolve the equation of the AVI model, we have the results of it, and then we can create a map with them. And one of the methods to map the results is with a Kriging interpolation. That is a statistical map that estimates values of variables of interest where there is no information. So we can discover another data that we can estimate only with this model. And the advantages of this is we can modeling the ideal nugget effect magnitude. We can create a smoothed interpolation surface with better prediction capacity. And the Kriging has been widely used in the interpolation of groundwater data. So it's a very important technique on the groundwater, the area in general. And here, on these figures, we can see the first results of the Kriging, like the Kriging precision and the Kriging standard error, represented by these colors. And we can see that the dark colors, like these dark blues, represents a highest standard error, mainly on the bordarians of the area. And it happens because on the center of the map is where we have most of the data. So because of that, the values are more precise. And here we can see the experimental variogram, the semivariance of the values, and some index too, like the nugget and the range. And finally, we can see the result of the hydraulic resistance by Kriging interpolation. And on this first map, we can see the colors on the area, the Upper Tietê Basin. And remember of the table that I mentioned before, the high vulnerability is 0 to 10. So all this color, red, orange, and yellow, represents a very high vulnerability of the aquifer. And here on the bordarians, the colors are more present. And on the center, we have a high vulnerability that is 10 to 100. And it's represented by this color green and blue. It represents 15 to 20. And on this map here to the right, we can see the standard deviation of the values. And on the center, the standard deviation is lowest than the bordarians. And so the final considerations of the work, the expectation is that the proposed method can be applied to other areas in Brazil because the database is openly available on IAH's. So every city or state in Brazil can download this data and make the same study that I showed. And it can also be applied in other countries that have well data. So you just need the information and the variables, and you can apply to the method. And the contributions is a better understanding of hydrogeological process and the information about the region's vulnerability and risks. So we can inform the governance and the population about it and creating some actions to prevent. And that is it. This is some reference that we used on this work. And thanks so much for listening. And if anyone would like to talk with me, please send me an email on this address. And that is it. Thanks so much.